how can we take a table of information, or even just a couple points, and turn it into the quadratic equation? Keep in mind, all quadratics are of the form y equals. We can do ax squared plus bx plus c, or we can do y equals, and then some sort of x minus something, which is called factored form, or we could even have graphing form, which is y equals a possible multiplier, x minus part of the vertex squared and part of the vertex. So when I look at the table in part A, I'm looking for key information that I see in part A. I see a 0 here, which tells me this is an x-intercept because the x value is provided. I see a 0 here, which tells me it's an x-intercept, meaning the x value is provided. And I see a y-intercept. I also see kind of the symmetry of how the table goes down to -6 and back up. So I see that symmetrical parabola shape. So what I need to do is write an equation for this. So if I know the x-intercepts, I know that in my factoring, in order to get an x-intercept of -3, I would have had to start with a factor that said +3. Because if I plug in -3 plus 3 would make 0. And my other factor to get an x-intercept at +2 would have had to be x minus 2. Because if I plug in a +2 for x, 2 minus 2 would make 0, giving me an x-intercept. So we'll write a y equals rule. We can always check this by checking the y-intercept. If we put in 0 for x, 0 plus 3, 0 minus 2, we'd get 3 times -2, which is -6, which matches our y-intercept. Let's look at the table for part B. In similar format, I see an x-intercept at -5. I see a y-intercept at -5. And an x-intercept at 1. So I'll start by making that y equals. If the x-intercept is -5, it comes from a factor of x plus 5. And if the x-intercept is 1, it would come from x minus 1. Because -5 plus 5 would make 0, or +1 minus 1 would make 0. Then we can check for the y-intercept if we simply just plug in a 0 for x, 0 plus 5, and 0 minus 1. We get 5 and -1. 5 times -1 is -5, which matched the y-intercept in the table, so our equation is good. Both of these equations are in factored form because the information that I saw in the table was those zeros, or x-intercepts. Here's 3 more quick examples. Part A. Dear Mrs. Quadratic, I followed all the directions given in your brochure about how to order a parabola. Tried to order a parabola that passes through the points 1, 0, and -6, 0. Only you sent me the wrong one. Please tell me how to order the correct parabola. So those look like x-intercepts, so we do y equals x minus 1 and x plus 6, because -1 minus, or 1 minus 1 will be 0, and -6 plus 6 would make 0. Problem B. Dear Mrs. Quadratic, I am a very disappointed customer. I wanted a parabola that hits the x-axis only once. And I see that you have no mention of this in your parabola pamphlet. Your company mission statement assures that my needs will be met no matter what. How should I order my parabola? So when we're doing this one, if it only has one x-intercept at +5, we would do x minus 5. But right now this is not a quadratic. So we can either write it twice, so we get the same x-intercept a second time, or we can write it as x minus 5 squared, because it's the same factor twice. Lastly, question C. We have, Dear Mrs. Quadratic, please help. I have searched through my entire brochure and I did not see any parabolas that would fit. I want my parabola to look like this. Okay, so I notice that there is an x-intercept at -3 and at +2, so I would do y equals x. If the intercept's at -3, I would do x plus 3 to get to 0, and x minus 2, because +2 minus 2 would make 0. Now here is a common mistake. Notice this parabola is facing upside down. What do we do to make this parabola go upside down? We have to put a negative out in front of the parentheses. This negative will tip the parabola upside down into the negatives. Actually, you can put any number in front of all of these equations. There could have been some number here, I'm just going to write the letter A, that is called a multiplier, telling it how steep to grow, how fast it should be changing, whether it should be positive or negative. And they didn't give us any more information besides the x-intercepts, so we didn't know how steep or fast the graph should be changing. So we're going to come across that in our next problem. We're going to skip the intro and just move on to question A. A journalist knows that the factored form of an equation is y equals a multiplier A, parentheses x plus b, x plus c. What do b and c represent in the factored form? Factored form tells you the x-intercepts, being mindful that it's actually at -b or -c, because you need the opposite value to give you a 0. Examine the graph at the right. That represents the height of Jen's toss. The journalist found out that the rule for the parabola was y equals a, parentheses x minus 0, parentheses x minus 8. So when I look at my graph over there, I see that x-intercept at 0 and that x-intercept at 8. But they don't know the value of a. Right, we know the x-intercepts, but that doesn't tell me that this graph has to go all the way up as high as past 30. So what do I do to cause this graph to go higher than 30? We need to pick any other point or coordinate that's on the graph. I'm going to pick the vertex. You could pick any other point. So my vertex looks to be at 4 and 32. So I'm going to use the coordinate 4, 32. Keep in mind the 4 is the x-coordinate and the 32 is the y-coordinate. So in my quadratic, instead of y equals, I'm going to put in that y-coordinate. 32 equals a. Instead of x minus 0 and x minus 8, I'm going to put in the x-coordinate of 4 at the vertex. Notice the only variable left is a for me to find what is that multiplier to get this graph to have a vertex all the way up there. So we'll do 4 minus 0 is 4. 4 minus 8 is -4. A. And if we multiply those, we'd get -16 times a equals 32. So to get the a, we would divide by -16. And we get a equals -2. This tells me that multiplier so that I could write my final equation. I would go back to my factored form, y equals x minus 0 and x minus 8. But now we need to put in that the a was a multiplier of -2. The negative makes the graph be going upside down or pointing downwards. So in general, the big idea is if you know the x-intercepts, use them to put the factored form. Put just a random symbol for a multiplier. We use a in front of the equation. And then pick any other coordinate from the graph. I chose the vertex to plug in as the x and y, so that will let you solve to find out what that a number is as your multiplier to write in your real equation.